You're thinking about physics wrong and I'm going to use D&D to talk about it. Well, okay, I can't guarantee you're thinking about it wrong, but you probably are, mate. In school, we often think of physics as a set of rules and a set of laws. So Newton's laws, for example, F equals ma, you are told that that is the truth, that is how the world works. Or that the gravitational force between two bodies is going to be described by this equation. But physics isn't learning a lot of facts. Physics instead is when we apply a model to the universe to try and describe it. So this one, F equals ma, that's not necessarily that the universe works like that, that's just the model that we apply. Newton's model is that the entire universe can be described by his laws of force and acceleration, and that any discrepancy from that is because of some force that we're not measuring. But that's just a model, and that's fine. It was eventually superseded in terms of gravity by Einstein's theory of general relativity. Again, just a mathematical framework. In a very pure sense, what physics is and what we're trying to do is to describe the universe in a mathematically sound way. So let's say, for example, we observe something like this, we then create a model that tries to fit that. I've not drawn it very well, but imagine it does fit it well. I did a different one because I did it so badly there. But basically what we do is we see these observables, we see things in the real world, and then we make a model to try and explain that. We can then take these principles, much like we can take Newton's 3 laws, and then we make a whole load of new predictions about the world. Because the idea is, if this is a good model for this data and is accurately describing the way the universe works, then when we build from these things that we've modeled as true, we should be able to get a new, interesting, true thing from that, if that follows. So we then take what we've got from our model and say, if these two things are true and we combine them, and we can combine them in a mathematical way, then we can say this should be true in some new space. And then we run an experiment to see if that is true. That's what physics is, fundamentally. These are both providing information about force. So we can put them together, equate them, and then we can derive this equation for the acceleration, which relates only to the mass of the body we're orbiting around, and also the radius, with this being a constant. So we can then go out into the world and we can measure these things to see if it works. Now I've done a bit backwards, we actually got this from this and this. But don't worry about that for now, okay? Fundamentally, this is what physics is. We see data and we fit a model. Once we have the model, we can make a whole load of predictions and try and break things, and that's what leads to brand new things like new technologies. This is what quantum mechanics is, this is what Newton's stuff is, what Einstein's things are. And this is why a lot of physics might come across as being totally unrealistic. You're like, no, the universe isn't doing that. Well, yeah, maybe it's not, but it's a useful mathematical model, and that's what counts. I hope that made sense. Either way, I hope you have a lovely day. Okay, bye.